NEC Section 300.33 addresses the use of supports for conductors. NEC Section 312.6 covers installation in a raceway, emphasizing how conductors should be managed within enclosures. NEC Section 312.8 pertains to splices and taps within enclosures, detailing requirements for making these connections safely and accessibly. NEC Section 364.41 focuses on panelboards and load centers, specifically outlining the regulations that apply to these distribution points. While the NEC doesn't have a direct prohibition against using Velcro to bundle wires inside panelboards and load centers, it also doesn't explicitly endorse it. The NEC mandates that wiring within panelboards and load centers be arranged in a neat and orderly manner, as stated in NEC Section 300.33. Moreover, NEC Section 312.6 stipulates that wires must be securely fastened within raceways. Within the electrical sector, the prevalent best practice involves using plastic tie wraps to bundle wires within panelboards and load centers. The primary reason for this preference is that tie wraps offer a reliable and lasting method for securing wire bundles without causing any interference with the functionality of the panel or load center. Conversely, Velcro isn't considered as secure as tie wraps. It could pose challenges when attempting to remove it for future wiring modifications. Additionally, Velcro has a tendency to accumulate dust and debris, potentially complicating the task of maintaining a clean panel or load center environment. While technically using Velcro to bundle wires in panelboards and load centers might be feasible, it's generally not advisable. Tie wraps are considered the superior choice for bundling wires in these applications, ensuring a secure, lasting, and organized wiring setup. Electrical installations must comply with the National Electrical Code, a comprehensive set of standards designed to ensure the safety of electrical systems. Panelboards and load centers, essential components of these systems, require careful attention to wiring practices to prevent hazards and maintain functionality. Bundling wires within these enclosures is a common practice, but the choice of materials and methods can significantly impact safety and future maintenance. This discussion focuses on the comparison between tie wraps and Velcro for bundling wires in panelboards and load centers, considering code compliance, industry best practices, and practical implications. The NEC Section 300.33 emphasizes the importance of neat and orderly arrangement of wiring. This general requirement aims to prevent overcrowding, facilitate heat dissipation, and make it easier to trace and troubleshoot circuits. While the code does not explicitly mandate the use of specific materials for bundling, it sets the expectation that wiring practices should contribute to a safe and functional installation. NEC Section 312.6 requires wires to be secured in place within raceways. Although panelboards and load centers are not raceways in the traditional sense, this requirement underscores the need for wires to be held securely to prevent strain on connections and potential disconnections. NEC Section 312.8 addresses splices and taps, which are often found within panelboards. This section mandates that splices and taps be accessible, meaning that they should not be buried within bundles of wires or otherwise obstructed. Industry best practices strongly favor the use of plastic tie wraps for bundling wires in panelboards and load centers. Tie wraps offer a secure and permanent method of bundling, ensuring that wires remain organized and do not interfere with the operation of the panel. They are readily available, inexpensive, and easy to install with appropriate tools. In contrast, Velcro is not widely used for wire bundling in electrical panels. While it offers the advantage of reusability and ease of adjustment, it lacks the security and durability of tie wraps. Velcro straps can loosen over time, especially in environments with temperature fluctuations or vibration, leading to disorganized wiring and potential hazards. Furthermore, Velcro can accumulate dust and dirt, which can compromise its effectiveness and make it difficult to keep the panel clean. From a practical standpoint, tie wraps offer several advantages over Velcro in electrical panel wiring. Firstly, they provide a more secure and permanent bundling solution, reducing the risk of wires becoming dislodged or tangled. Secondly, tie wraps are less likely to be affected by environmental factors such as temperature and humidity, ensuring long-term reliability. Thirdly, tie wraps are generally easier to install and manage in tight spaces, especially when dealing with large numbers of wires. The choice between tie wraps and Velcro for wire bundling in panel boards and load centers involves careful consideration of code compliance, industry best practices, and practical factors. While Velcro may offer some advantages in terms of reusability and adjustability, it falls short in terms of security, durability, and cleanliness. Tie wraps, on the other hand, provide a secure, permanent, and neat method of organizing wires, aligning with NEC requirements and industry best practices. Therefore, tie wraps are the preferred choice for bundling wires in electrical panels to ensure safe, reliable, and maintainable electrical installation. When evaluating the suitability of materials for wire management inside electrical panels, several key factors must be considered, including the National Electrical Code requirements, industry norms, the longevity of the materials, and any possible safety concerns. Electrical panels are essential elements of electrical systems, and their proper arrangement is crucial for both performance and safety. The NEC provides specific guidelines on wire management within these panels, emphasizing the importance of neatness, accessibility, and secure connections. Industry standards, derived from years of practical experience, further refine these guidelines, suggesting best practices that promote reliability and ease of maintenance. The choice between tie wraps and Velcro as wire bundling solutions brings up important considerations. Tie wraps, usually crafted from nylon or other durable plastics, offer a firm and lasting hold. They are made to withstand the rigors of an electrical environment, including temperature changes, vibration, and exposure to chemicals. Once fastened, tie wraps offer a secure bundle that minimizes the risk of wires becoming disorganized or strained. Velcro, distinguished by its hook and loop design, offers a reusable and adjustable alternative. This feature may be beneficial when anticipating future modifications or additions to the wiring within the panel. However, the long-term reliability of Velcro in electrical applications is a topic of concern. The adhesive backing can degrade over time, particularly when exposed to heat or humidity, potentially causing the Velcro to lose its grip. Moreover, the fabric loops can accumulate dust and debris, diminishing their ability to securely fasten. From a safety perspective, the selection of wire bundling materials must address potential hazards such as electrical shorts and overheating. Tie wraps, when properly installed, help maintain a compact and organized bundle, reducing the likelihood of wires rubbing against each other or against sharp edges. They also help in heat dissipation by allowing air to circulate around the wires. Velcro, if not securely fastened, may allow wires to droop or sag, increasing the risk of contact with grounded surfaces or other conductors. Furthermore, loose wiring can obstruct airflow, potentially leading to overheating and insulation breakdown. When weighing the benefits and drawbacks of tie wraps and Velcro for wire bundling in electrical panels, it is important to consider the particular application and the long-term objectives of the electrical installation. For installations where stability and durability are vital, tie wraps offer a dependable solution. Their proven performance in electrical environments, combined with their resistance to environmental factors, makes them a preferred choice for many electricians. On the other hand, Velcro may be appropriate for temporary installations or situations where frequent changes are anticipated. However, it is essential to regularly inspect Velcro bundles to ensure they remain secure and free from debris. In conclusion, the decision to use tie wraps or Velcro for wire bundling in electrical panels should be based on a thorough evaluation of the NEC guidelines, industry standards, safety considerations, and the particular requirements of the installation. While both materials offer distinct advantages, tie wraps generally provide a more secure, reliable, and long-lasting solution for maintaining neat and orderly wiring within electrical panels. The neat and orderly arrangement of conductors within electrical panels and load centers is not just a matter of aesthetics, it is a critical safety and functionality requirement detailed within the National Electrical Code. This arrangement directly impacts the ease of troubleshooting, reduces the risk of accidental shorts, and improves the overall thermal management of the panel. When considering the methods for achieving this arrangement, the choice between plastic tie wraps and Velcro wraps often arises. Plastic tie wraps are a staple in electrical work due to their durability, ease of use, and cost-effectiveness. Once secured, they provide a firm, unyielding hold that keeps conductors tightly bundled. This is particularly important in environments where vibration or physical stress could cause conductors to shift or become dislodged. The NEC does not explicitly endorse or prohibit the use of tie wraps, but the resulting neat and workmanlike installation they facilitate aligns with the code's general requirements for safety and accessibility. Velcro wraps offer a different approach to conductor management. Their primary advantage is reusability. They can be easily loosened and refastened as circuits are added or modified. This flexibility can be appealing in dynamic environments where changes are frequent. However, the long-term reliability of Velcro wraps in electrical panels is a subject of debate. The adhesive backing can degrade over time, especially when exposed to the heat generated within a panel. Fabric loops can also collect dust and debris, which can compromise their ability to maintain a secure hold. The NEC emphasizes the importance of maintaining accessible wiring. This means that conductors and connections should be readily accessible for inspection, testing, and repair. Overly tight or densely packed bundles of conductors can hinder accessibility, making it difficult to trace circuits or perform maintenance. Both tie wraps and Velcro wraps can contribute to this issue if not used judiciously. It is important to strike a balance between securing conductors and maintaining accessibility. From a practical standpoint, the choice between tie wraps and Velcro wraps often depends on the specific application and the electrician's personal preference. Tie wraps are well suited for installations where long-term stability is paramount and changes are infrequent. Velcro wraps may be more appropriate in environments where flexibility is essential and the risk of loosening or degradation is carefully managed. Regardless of the chosen method, it is essential to adhere to the NEC general requirements for neat and workmanlike installations. This includes avoiding sharp bends in conductors, maintaining adequate spacing between conductors, and properly labeling all circuits. These practices not only enhance safety and functionality, but also facilitate future troubleshooting and maintenance. The use of cable management accessories, such as cable trays, dividers, and strain reliefs, can further improve the organization and accessibility of conductors within electrical panels. These accessories help to separate different types of conductors, prevent chafing, and reduce stress on connections. Ultimately, the decision of whether to use plastic tie wraps or Velcro wraps for conductor management in electrical panels should be based on a thorough understanding of the NEC requirements, industry best practices, and the specific needs of the installation. By carefully considering these factors, electricians can ensure a safe, reliable, and maintainable electrical system.